Imagine a world where we could literally bury our climate problems underground. Sounds like science fiction, right? But here's the reality. One of the most debated solutions to combat global warming is carbon capture and storage, locking away carbon dioxide beneath the Earth's surface. But here's where it gets controversial. How much carbon can we realistically bury? And is it enough to reverse the damage we've already done? Let's dive in. The fight against climate change boils down to a simple yet daunting challenge. We need to stop pumping greenhouse gases into the atmosphere. However, the truth is we've already emitted so much carbon dioxide that even in the most optimistic scenarios, experts warn we'll overshoot safe temperature limits. This means we won't just need to stop polluting. We'll need to actively remove CO2 from the air and store it somewhere. And this is where carbon burial comes into play. Carbon capture and storage, CCS, involves trapping CO2 emissions from sources like power plants or directly from the air, then injecting them deep underground into geological formations like depleted oil reservoirs or porous rock. The idea is to keep that carbon locked away for centuries, effectively turning back the clock on global warming. But how much can we actually achieve with this method? Estimates vary. But some studies suggest we could potentially store hundreds of billions of tons of CO2 globally, a significant chunk of our historical emissions. And this is the part most people miss. CCS isn't just about burying carbon. It's about buying us time. Even if we transition to renewable energy rapidly, the CO2 already in the atmosphere will continue to trap heat for decades. CCS could help us avoid the worst-case scenarios of climate change, such as catastrophic droughts, famines, and extreme weather events. But it's not a silver bullet. The technology is expensive, energy-intensive, and faces public skepticism over safety and scalability. Here's a thought-provoking question. If CCS is such a powerful tool, why isn't it being deployed at a larger scale? Some argue it's a dangerous distraction from the urgent need to cut emissions, while others see it as a necessary part of a multi-pronged strategy. What do you think? Is burying carbon underground a game changer or a risky gamble? Let's spark the conversation in the comments below.